Hello friend, welcome to the Pure Mathematics channel. It is pre-algebra class lecture 8. In this lecture we want to explain or introduce real number line. It is very important when we studied real numbers, algebraic numbers, and we have to know the real number line because in so many branch of algebra, in graph theory, every where we can use, especially in intervals, also we can use a real number line. It is very important. So we are going to explain this concept, real number line. Real numbers are represented graphically by a real number line. The point 0 the point 0 on the real number line is origin. The number on the left, the right of U is positive numbers. Numbers on the right of U are positive, and the numbers on the left of U are negative, as shown on the following figure. Here we define real number line. Real number are represented graphically by a real number line. The point 0 on the real number line is origin. The numbers on the right of O are positive, and the number on the left of O are negative, as shown on the figure, on the following figure. Here, as you see, it is the origin. It is a real number line from minus infinity up to positive infinity, plus infinity. It's called real number line. Here here 0 is the origin, and 0 doesn't have sign. The right side of 0 are located a positive number, and the left side of 0 located negative numbers. Totally, it's called real number line. We can show every real number on the real number line. Here is an one-to-one relation between numbers and a real number line. Every number has a specific location in real number line, and every real location has a specific numbers. So we can show every real number on the real number line. Example, show the following numbers on the real number line. Number 1, here we want to show these numbers in real number line. Minus 2, number 2, 3.5, number 3, minus 7/2, number 4. Yes. Number 4, 0.75, 5p7, 6, minus 2.4, and so on. We want to show all of them in real number line. Now we draw two real number line. Now we want to sketch every number here. First one, minus 2. Minus 2 is here. From origin we count 1, 2. It's minus 2. Actually, it shows it's called minus 2. Minus 2. Actually, it is minus 2. 3.5. We count from here. 1, 2, 3. 0.5. Here we divided from 3 up to 4 in 10 times. Here is 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here 1, 2, 3, 4, 5. Here is 3.5. It means from here from origin up to here is 3.5. 3.5. It is the location of 3.5. Actually, it is the middle between this 3.5 is between 3 and 4. 3.5. Next one, minus 7/2. We know that it is minus 3.5. Minus 3.5. It is the sign of number is negative, so we come in left side. Here from same things. Here we divided 1/5 10 times from 3 up to 4. Minus 3, we have 3. 1, 2, 3. But from 3 up to 4 we want to divide by 10. 3, 4, 5, 6, 7, 8, 9, 10. Here is 5. Here is 5. Actually, here is the location of minus 3.5. 3.5. From here up to here is minus 3.5, or we can write minus 7/2. First we change it to the decimal number, fraction or square root, everything. We change it to decimal number, then we can show in the real number line. Here we have 7.5. It is approximately is equal to, if we round off this number, it is approximately is equal to 0.8. 0.8. Therefore, from here, from 0 from 0 up to, here is 0.8. From 0 up to 1, we divided in 10 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here is the location of 3.5, 3.8. Yeah, sorry, 0.8. Here is 0.8. 0.8, less than 1, near to 1, but less than 1. P 3 point, it is equal to 3.14, 15, and so on. It is approximately is equal to 3.1. 3.1. It is here 3.1. How we can write here? From here up to 3.1. 3.1 is here. It is 3.1 here. It is actually P. P is equal to 3.1. 3.1. Also, we can show P is equal to 3.14, 15, and so on. We can show as like this. Next one, minus 2.4. Minus 2.4. Here it is enough. In the next 3.4 is here. Minus 2.4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4 here. Minus 2.4. Minus 2.4. Minus 2.4. Actually, 2.4, the location of 2 minus 2.4 is here. Minus 2.4. Next one, square root of 2. Square root of 2, it is minus plus 1, plus 2, and plus 2. Square root of 2 is equal to 1.41, and so on. It is approximately is equal to 1.4. 1.4. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. Here is square root of 2. Square root of 2, it is equal to 1 point, it is approximately is equal to 1.4. It is the location of square root of 4. Minus square root of 2 minus square root of 2 is you should show this thing by yourself. Also, we can show it if it is the origin 1, 2 minus 1. Here is minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is minus 1, minus 2, it is 0. From here up to 7, here it is minus square root of 3. Similarly, minus e is minus e, it is approximately is equal to minus 2.718, and so on. It is approximately is equal to minus 2.7. Minus 2.7. It is minus 2 minus 3. Minus 2.7 1, 2, 3, 4, 5, 6, 7, 8, 9. Here is E. It is minus E. Actually, here is minus 2.7. This location. And minus 2, 3 plus P, 3 plus P. We know that. We have 3 plus P. It is equal to 3 plus 3.1. P is equal to here 3.1. If we add these two numbers, it is equal to 6.1. It is approximately is equal to 6.1. 6.1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, from 0, from here up to here, it is 6.1, or we can write 3 plus P. It is the value of here number 3 plus P. 3 plus P. 5 plus square root of 3. It is equal to 5 plus square root of 3, 1, 7, 7, 1, 7. It is approximately is equal to 6.7. 6.7 is here. Yes, it is called 5 plus square root of 3. Similarly, we can show every real number, we can show on the real line. It was the lesson of this lecture 8. Thank you.